touched head because that's a good place to be. And I need to be here. But also here. Well, let's see what's going on. And then try to close everything that can show me any kind of notifications. And now I'm going to really pray.
All right.
I think I'm sharing something.
You
Am
are.
I am.
Is that
Okay.
a celerized scheme?
Yes, that's that's contrasting, right, with the terminal.
Yeah. So do you want to turn off your camera for the stream?
I am turning off my camera.
Perfect. All right. So if you try to build this,
yeah, just
command should be make check desktop escape.
yeah. I haven't been building that yet, so I'll just build the state we've got. I'm in the underscore build directory, which is hopefully the one.
Yep.
Okay, I got the same failures we've seen. It seems.
So we've looked at the 121, that's unfixable easily. 133.
Let's take a look. So yeah, 121 is the one we were talking about last time.
Right.
When we got it down to one leak. And then there is back here 133. And that one was much more severe.
Well, that doesn't really mean anything.
Okay.
If there's one object that leaks in a loop or one object that has references to other objects, then they'll leak. So how do you fix this?
Oh, that's
how
a great.
How do you find this?
How do I find it? What does the test do? The test does the things all of the tests do. It seems that there is the actual test content. And how to approach that one? There is TS, which is I think we've thought about it. We talk about it as a transaction set. Mm-hmm. And this is the there are also other functions from RPM module, ones that open files. And so this comes from RPM2. Basically everything here comes from RPM here at those lines.
So the easiest way to find a reference leak with the showref count is you comment out half of the test and see if it appears in the part that's not commented out.
All right. So binary comment.
Yep.
Let's
Binary search.
binary search. Let's try to find it. Tests. RPM Python add. I'll open it conveniently somewhere here. The test is
Line 740.
is it archive 1? Yeah. So here we are. This looks like
Just remove the whole
right.
loop.
Okay, does it work? Can we comment in the .m4 format? Who knows? We'll see. Will that do anything? It does something. Will that? Hey, will that do something? It did.
So there's
But
still a leak.
now it
So
doesn't
comment
change.
more.
So how about I have like a feeling that this may be the offender, but of course nothing to support that. Will that?
Well, apparently it's a check for archive. Yeah, that solved it.
Yeah, so the test passed completely, right? Okay, so that solved it. So that was not the offending line.
Nope.
There was some other offending line. There's payload. It's just.
Well, there's another call to RPM FD open, so maybe try the next line as well for this iteration.
Yes. So this would just create a variable and add some data to it. Store some data in it. And
that's clean too. So files.archive is the offending line for the test named archive1. That checks out. So now let's find what C function is this calling.
Okay, archive. We are.
So there's a little trick. If the C function is actually, if this is implemented in C, then it needs a name for Python to name the function, and that will be a C string. So it'll be in double quotes. So do git grep, single quote, double quote, single double. You need to quote the double quotes.
Yeah.
Or that. Yeah.
Like that.
And archive in there. Yep.
Nothing, but maybe, am I in the right? What if I did this here? Pressure.
Okay.
Can you just close the door?
Yep. So rpm files.py, rpm files-py apparently has an archive function. Let's see. In C, it's called rpm files archive. So yeah, this grep pattern is very effective.
That's nice. That's really nice. So there is RPM files. C function that
has leak.
Has leak. What do we see here? It takes an RPM files object and some arguments and keyword arguments.
So add a new line at the beginning of the function and put in return or py return none. Py with a capital P underscore return none. Yeah, all capitals.
Yes.
That's the thing.
Like that.
Yep. And let's do a binary search again.
Okay.
It doesn't really start in the middle because we want to be sure that leak doesn't happen if we put this here. But then we can start putting it in the middle.
Where are we? We are very, very green now.
Very green. Make sure the call is not commented out still in the
So,
test.
Okay, back to the test. Yeah, it's here. So that was the offending line. That was
Great.
that
Okay,
was
so
that,
put the
so
return in the middle and let's try the search again.
here we are.
That's usually quicker than trying to understand and review the whole function.
Okay, somewhere here. Like here. And it's
Still no leak.
again. So I go further. How about this line I like?
It's interesting that the test passed without the loop there.
Ah,
There's the leak.
there it is. And what does it say? Ah,
There's
it's the
the
number
leaks.
missing.
Okay, let's see what those few lines do. So it does pyarg, parse tuple, and keywords. That is a function that takes in the input arguments and keyword arguments and sets them as Python variables. And all of those should be borrowed, I believe. Well, one thing you can do is put the PyReturn none in the middle there before the RPMFD from PyObject.
That one is Python function, and that one does not look like a Python function. So
yes, but you can call a Python function and get a reference that is not freed.
Yeah.
So it is the RPMFD from PyObject.
Yeah.
So what does this do? So it gets a module state. We added that recently. It gets an FDO source, which is a Python object. Great. And it gets back an FDO. So I would say this unwraps the FDO source object and gives you the RPM thing that's hiding inside it. Can you go to the definition of RPMFD from PyObject?
Yes, I can. So this is the header file, and the definition says.
Oh, this is interesting.
There is some incref, there's some decref.
Okay, so a reference counting operation is on line 27. We call the RPMFD type with an argument of object. So all the arguments should be borrowed, which they are. And if we get back an FDO, which should be reference counted, right? So FDO is a Python object. So then there's some error handling if the FDO's FD there's an error on the FD, it does stuff, decrements the FDO, and then it says FDOP, which is the output argument, to the FDO. Right? And what happens to the object called FDO? It stays encrypt and is not returned anywhere. So it needs a decref just before the return.
Basically like that, or it could be just good.
Well, this is probably simplest right now.
So let's try it now. Or not yet?
Yeah, try it.
Oh, I got. Oh, wow.
Yeah, this is a bigger problem. Can you see why? Oh no. Oh, sorry. We set the output to FDO. Right. Sorry. So that doesn't leak the reference. That gives the reference to the caller.
Oh, I didn't get it.
I got confused. Okay, so this function's last argument is an RPMFD object star FDOP. Right? So the normal Python object are PyObject star or something object star, pointers to the object. This one is a pointer to such a pointer, and this function will fill in that pointer. Right? So instead of returning the value, it takes the address of the memory which should write the output value. Right?
Yeah.
And when that happens, it usually means that the caller is now responsible for that output.
Okay.
Right? Because if we do this decref here, then this object gets deleted and this pointer now points to deleted memory. So remove that decref and let's go back to the caller.
Let's go back to the caller. This is the
So
caller.
this gave us ownership of FDO.
Yes.
So where do we get rid of it? We do RPMFD get FD, which if it's written following the conventions, it should get borrowed copy of FDO.
We can check it out. Where are we? Okay.
Oh, and that returns FDO's FD. And now the question is FDO's FD still valid if we remove the FDO? What is the FD anyway? Can you look at the type? Oh, it's FDT. Okay. Oh, it's at the line that's half missing at the top.
Yeah. Okay.
FDT, and what's FDT?
What's FDT? FDT is. No, what it is.
It's in some header somewhere. Probably.
VM archive sounds like a good no.
So maybe it's an type def. Oh, type def struct FDS. Pointer to a struct. And RPM types.h.
I RPM
types.
I'm in the wrong place.
Yeah, I guess that would be inside the RPM library now, not the Python bindings.
Ah, no, one more time. So, RPM types annotation. Here is founded and FD tab.
Yeah, so it's some structure that probably needs an owner if it's a structure. Right, so let's look back. So it's a pointer to something, which probably means if you copy it, well, it probably means it should be reference counted or something. So what does this do? This takes the FD and calls rpm-fi new archive writer or rpm new archive reader on it. And I would hope if you give fd to such a function, then it would take ownership of that fd. So after this if-else block, it should be okay to decref the fdo that holds the fd.
Okay, we can try it.
It's a bit abstract, not knowing what any of these things are and do. No, the FDO, not the FD. FDO is the Python object. FD is the RPM structure. All right, try that.
And we are green.
Uncomment the rest of the test.
Ta-da!
Nice. So this can just go as a pull request.
Just like that.
RPM. One thing I would check is the documentation for those functions. The rpm-fi new archive writer. Let's see if that says anything interesting.
What does... Okay, security warning, of course, that's the right RPM page.
Could you...
I will.
The screen?
I just need to send it to another tab. It should be visible now.
Yep, the browser is visible.
And there is...
Get new file iterator. The regular files can be retrieved, and so on and so on. Okay, click the FDT link. Oh, it's an RPM-IO file descriptor type. Great.
I guess, yeah, it's referencing.
Well, go back. Who knows how to deal with this one? Should that file be closed, or does the archive reader close it afterwards? don't know.
Here is the writer says that make sure that you close
The RPM FI. So maybe click the RPM FI archive close.
Close payload archive.
And
Can-
hopefully that'll close the file as well. Who knows? So we wrap it. So we make a Python object from that archive, and we return it to the caller, and then Python code does something with that, and it should be closed when the Python object is deallocated. So that should be fine. Archive wrap is a Python wrapper. I don't think there's documentation for that.
Somewhere. Does it say anything about itself? No, it doesn't.
Well, all of these wrap functions pretty much do the same thing. They take an RPM library object and they build a Python object that contains it. So you can see this gets the allocation function in a way that's compatible with older versions of Python and newer ones as well. Allocates the object, sets the stuff inside, and returns it. So if you go to the definition of the type, I think that's in the caller. Oh no, RPM archive type spec. So it has slots and just above this on your screen.
Okay.
So it has slots, and one of the slots is PyTP dialog, line 262. Right, so if you go to the RPM archive dialog function, that should be somewhere up there. That calls RPMFI archive close. Woo! Oh, and it frees the files as well, so hopefully this will close the underlying FD. Right, so great. You can take this, make it a pull request right now.
Should I do it just now, or should I just make a mental note for that and send it later? Should there be a comment here about that? What's happening?
I don't think you need a comment for the deck graph. What would you want to say? I mean, we're not using the Python object anymore, so we remove our reference to it. That's explaining what the function does, pretty much.
So what just happened? We are avoiding the leak, the memory leak. Is that the way?
Reference leak.
Reference leak. Is there like terminus technicus for that? Like what's going on?
Well, avoiding a reference leak is perfectly normal. Avoid a reference leak in maybe Python reference leak, since that's Python wrappers. In whatever the name of the function is.
Okay. RPM's archive. Okay.
Yep.
That's somewhere there, and where it will open. Not entirely sure. Yes, exactly. That was it. Oh no.
Probably want
Okay.
a new branch and rebase it. Oh, you are on a new branch. So
I want.
git rebase -I master.
Yeah. Oh my god. We are far, far from master. Gilbert-based interactive.
Origin /master. I don't know if your master's up to date.
Probably master.
Now delete everything but the last line here.
Yeah.
Nice, VI magic. And run the test just in case.
Yeah. Build and where am I? So I will do that. That looks much better. Oh, okay. That's probably some config issue because I've got Python 3.14 and we don't, or something like that.
Right. Untangling the the config settings will be
Oh,
oh.
debug. Why debug?
Oh, what? Isn't this rebased on like master?
I'm going to do one more thing. Oh, wait. Okay. That's it. It is. It's really the master. It's today's master. No. Much better. Not really.
RPM Sequoia. It's too new. Oh dear, oh dear.
That's probably me.
No typo there.
Do I? Be smarter. No.
Well, maybe it's better to leave it to the RPM test suite on GitHub. That's set up correctly.
Hopefully. So yeah, it's still one commit. It says what it does. It does the thing it does. Let's do that. And
I don't know how well you know the maintainers. You've talked to them before, right? They
yes.
know you're doing the Python stuff.
Well, we'll get to that. We'll get to that. So we're somewhere here.
All right. So the reference counting is good now.
Was there one more issue there, or that was only our test?
That was our non-test, yes.
Okay, archive. Why is that? Because I committed it to a different branch and it's not here.
Probably.
Is that
So that's fine.
okay? No. Okay, so
we're good.
we're good.
There's
What was this?
there is one more check that we could try that I've noticed in the test output.
Mm-hmm.
If you go to some failing test,
I will. So let's take that one, the leaking one, not anymore.
so on line 30, that's the invocation. It says detect leaked 0 for ASAN options.
Mm-hmm.
Right. Do you have any idea what ASAN is?
I don't.
So that's the address sanitizer. And that's a special build mode of some compilers that detects stuff like memory leaks or accessing memory that doesn't belong to you and stuff like that.
Mm-hmm.
And well, Python was until recently such a mess with regards to ASAN that this wasn't very useful. But if you look at the build bots now, so this is an interesting thing to know about Python. If you go to buildbot.python.org,
How?
buildbot,
Buildbot. Python.org.
yes, could you show the browser?
Oh well. Here it is.
So that's the post-merge CI, older than GitHub, or at least older than Python's move to GitHub. So in the navigation bar on the left, go to release status.
Wow.
Thank you. I had a lot of fun with that CSS. So if you go to one of the failing ones, like click the 311,
Mm-hmm.
this says Arch Linux usan function, and on the 310 right below it says Arch Linux asan debug. So how BuildBot works is people have their computers under their desks over the world, and they want to contribute something to Python, so they turn their machine into a build bot, and they have some weird configuration on their machine, and it builds and tests Python, and then it reports the results here. And some time ago, somebody added configurations for address sanitizers. I think that was Pablo. And they're all green now, except for very old branches that don't get backports anymore. So you can see ASAN doesn't show up in 311. It shows up in 310 because there's some problem in 310. And it's the buildbot configuration is quite annoying, and there's no good way to disable this for older branches, so it just turns up as red. Anyway, if you have anything better than 310, address sanitizer problems in Python itself should be already fixed. So you can go back to RPM tests, or if you want to look at this more, and if you remove the ASAN options detect leak 0 from somewhere.
That will be probably a local at, if I remember correctly. actually.
Yeah, let's see what that does. You probably want the LD preload ISAN loop.
I want to keep LD preload.
Yes.
Right.
So how these sanitizers work is they load a special library that hijacks calls to malloc and libraries like that.
Mm-hmm.
And apparently that needs this LD preload variable.
Oh.
Nice!
Nothing happened. That's the best news.
Great.
Comment is no longer needed. What we are doing here, we are basically we are using features from Python 3.10, and we backported some features from Python 3.11. So right now the code of RPM is Python 3.10 compatible.
Mm-hmm.
So that is, I guess, all right. Removing this thing.
I guess 3.10 is not entirely green on the ISAN builder, but that's a different issue. So if you go back to the buildbot page,
Mm-hmm.
to the failed ISAN builder in 3.10,
Yes.
so there's like two of them. So if you open the first X in the row in a new tab, that's the last failed build, and if you click on stdio for the tests and go down, you see that there is one failed test, and that's test SSL.
Mm-hmm.
So the actual problem here, you can click the raw button if you want the whole and the entire logs, but the actual problem here is that this buildbot runs Arch Linux, and Arch Linux includes a very fresh version of OpenSSL, and I think you've been getting some of these errors in Fedora as well when upgrading SSL. Some new version of OpenSSL changed the error reporting so that it uses another of its like 3 or 4 ways you can report an error, and Python wasn't really updated for that. So it's been fixed in 3.11. There's a pull request open for it for 3.10, I think now, but it'll just take a bit of time.
Mm-hmm.
Anyway, yeah, so it should be fixed on all relevant. I mean, the actual address sanitizer issues should be fixed on all relevant Python versions. So this could be another pull request to RPM. See if their CI now works with ISAN.
Let's do that. And again, I need wait. Now I got again. Yeah. Okay, we've got this show ref count, which we don't want to have.
There
Yes.
might be one. one issue with this, and that's the test that failed because of the bad ref counting we didn't fix earlier. Anyway, yeah, go ahead, commit this, and then let's go back and retest.
Okay. This looks like something I want to. And I want to tell them that Python is no longer a mess.
Yes.
Regarding us.
Run Python tests with Python. It's probably the better. This works well as a second line of the commit message.
Okay, what do you propose? Sorry.
Run Python tests with ASAN. Or don't disable ASAN for Python tests.
I want my second line.
But before you send that pull request, let's go back to the full branch with everything and run the tests again.
All right. And this is the place we want that. Yep. And without the show ref count?
Oh, keep that there. We change the tests to expect that.
Okay.
And look at test 121.
Test 121. Here we are. There is the one.
So the address sanitizer didn't complain.
That's true.
That's good.
Right?
Okay, so I can make the pull request. Nice.
Okay.
Hopefully we didn't fix something. Oh, well, wait, we might have fixed something in this long branch. How to test if the ASAN thing is actually maybe you write it in the message in the pull request. Something like, this is cherry picked from a longer branch that might have fixed something in our usage of Python APIs. I'd like to use the CI to check this. Yep, Python itself is now tested with ASAN.
Okay.
Upstream. Okay, one typo changes to changed the first line in the middle. Yeah. Okay.
Very productive.
And let's see if the tests there fail or not.
I will, if, oh, all checks have passed with my previous pull request.
Nice. Does it actually run all the tests? Could you look at the details there? Run the test suite. Nice.
And
All great.
all of them. Is there a Python there? I think there was. Somewhere here, right?
Probably uses different numbers.
Yeah.
Archive 1.
Nope, not 2, 1. Okay, okay.
Yep, that's the Python test.
Great.
And let's see it. Let's see the ASAN one.
How long does it take? Oops.
I don't know if they
Right.
enable ASAN. But I guess if it will pass the tests, then it's a good change to make.
Great. The tests are running.
Let's see if there are any failed Python
Oh,
tests.
oh, yes.
There it is.
Oh, yes.
I wonder if the CI will
Tell us something
us.
about it. Can it be that something about debug versus standard Python?
I'm pretty sure it's something related to the hack we did for the leaks for the module state or something like that. I'm pretty sure we fixed something in that long branch.
Okay.
It's interesting that all the Python tests failed.
So does it say which Python it?
Yep.
Oh,
13.
13 too. Okay.
How many tests are there?
I think not so many, but then not only Python tests failed.
Not only Python tests. That's curious.
RPM query, JSON format 2.
Huh.
RPM depth match, provide require pairs.
I'd be interested to look at that test.
require.
That looks like Python syntax. Aha! It's a Python test.
All right. How about JSON format too?
And the commit changed the definition of Python tests only, so
Mm-hmm.
yeah, there's some Python there.
Arclient test check.
I think the test is done. Could you check if there's any interesting output? Oh, indirect leak. Let's study that a bit further. Dictionary size, import star. VA call.
A bit bigger. So that's
Huh. Okay, it's leaking something that's been imported. That's not very interesting, honestly. Okay, yeah, I guess you can close the PR, apologize for the noise, and say that we'll revisit this later.
all right. Is there any kind of 45 failures?
Testing module import. Right? Every single test will fail.
Okay.
Say that.
I can add something.
I'll revisit this later.
Okay.
All right. And it's 6 o'clock
Okay.
already,
Definitely.
so I guess this was a productive session.
Yes, it was.
Well, it's a single line commit, but still an improvement.
At least they know that we're still working on that.
They know that we're checking thoroughly, right?
Yeah, exactly.
Okay, so next week, I guess it'll be untangling the test config changes from the isolation.
All right. I would like to talk about your time possibilities next week because Thursday to Saturday there is Flock to Fedora in Prague, and I'm there. So Monday, Tuesday, Wednesday, I could find an hour from my detached workplace at Miro Hrončoks.
Monday, Tuesday, Wednesday. So I guess that would be Monday only.
Monday works for me though. So if you can, I would do that on Monday.
All right.
At 5.
Okay. Yeah. If I'm not there, call me on the phone. Hopefully
All right.
I'll remember.
All right. I will. Thank you for today.